So Q equals to delta H2 equals to Cp T2 minus Ta. Cp value is 29.094 and T2 is 298.15 minus 1490.75. So that gives the heat transfer and enthalpy, change in enthalpy. So that value is minus 34703 joules. Now coming to the work done. Coming to the internal energy delta U equals to Cv T2 minus Ta. So Cv value is 20.78 and T2 minus Ta 298.15 minus 1490.75. So the delta U value is minus 24788 joules, and the W equals to, from the first law of thermodynamics, du equals to dq minus dw, or W equals to delta U minus the Q. So delta U, this is 2, delta 2 and 2, so delta minus 24788 plus Q 34703, it gives the W value. So W is 9915 joules. So now for the entire the process, that is from state 1 to state 2, so the total net heat transferred, that is Q equals to Q1 plus Q2. So Q1 is 24,788 and Q2 is minus 34703, that is minus 9915 joules. And W, the work required is to reach the state 1 to state 2, the work required is W1 plus W2. W1 is 0 and W2 is the 9915 the joules, so 9915, and the change in internal energy, that is delta U1 plus delta U2 value is 0 because here the initial state temperature and the final state temperatures are same. That means temperature is constant. So for constant temperature process, the change in internal energy is always 0. So similarly for delta H1 plus delta H2. Here also H is a function of temperature and the initial temperature and the final temperature both are equal. Therefore delta H equals to 0. So these are the amount of heat transferred and the work required and the change in internal energy and enthalpy for the first process, that is the heating at constant volume followed by cooling at constant pressure. Now coming to the second process, that is isothermal compression. So now second process, isothermal compression. For these also the PV diagram is required. So initially it is at state 1. The compression means the volume is reduced. So it's like the curve is like this. So 1 to 2. This is state 2 and so the path 1B2 is a isothermal compression path, and for isothermal compression delta U and delta H, for isothermal process delta U and delta H are 0 because the temperature is constant, and the work done and the heat transfer Q equals to W equals to minus Q equals to minus W equals to RT ln P1 by P2. So R is 8.314 and T is temperature is constant 298.15 and the pressure, the P1 is 1 bar and P2 is 5 bar. So finally the value is 39 minus 3990 joules. So Q equals to minus 3990 joules and W equals to 3990 the joules. This is for the second bit, that is isothermal compression. Now coming to the third process, that is adiabatic compression followed by cooling at constant volume. See, second we have to draw the PV diagram. The PV diagram first, the air is at initial state 1. To reach state 2, it follows two paths. One path is adiabatic compression. So wall compression means the volume is reduced than cooling at constant volume. So like this, volume is constant. So this is the state 1 and state 1 and state 2. The directions like this. So one, and this is take A state, this is state 1, state A, then state 2. Now consider the path 1 to A. 1 to A is adiabatic compression path. Adiabatic compression path, and we know the initial values P1. The P1 value is about 1 bar, and we know the V1 value. So V1 is 0.02478, and for second path we know the V2 value, but V2 equals to VA. Why? Because it is a constant volume process. So V2 equals to VA equals to 0.00495 cubic meters per mole. And we know the temperature value T1 equals to 298.15 Kelvin. But TA, we don't know the TA value. We have to calculate the TA. So for calculation of the TA for adiabatic compression, we have one relation between temperature and volume. So that is T V per gamma minus 1 equals to constant. With the help of these relation, we have to calculate the TA value. So T1 V1 per gamma minus 1 is equals to TA VA power the gamma minus 1, or TA equals to T1 V1 by VA whole per gamma minus 1, where gamma is nothing but Cp by Cv. So gamma equals to Cp by the Cv, that is 1.4, and T1 is 298.15 and V1 is 0.02478 by 0.00495 whole per 0.4. It gives the value of temperature 567.57 kelvins. So after getting this temperature, then we have to find out the Q value, and for adiabatic compression, adiabatic process means there is no heat transfer between the system and the surroundings. Therefore Q equals to 0 and W equals to delta U here for adiabatic process, and this is CV delta T, that is T1 minus, sorry, TA minus T1. CV TA minus the T1, and CV value is 20.785 and TA is 567.57 minus 298.15. So del W equals to delta U equals to 5600 joules. Similarly, for the constant, the second part, that is for the constant volume process. Constant volume process, the W equals to the PdV, that is 0, and for constant volume process Q equals to delta U, that is integral, sorry, CV T2 minus TA. So CV T2 minus TA, after substituting we get minus 5600 joules. So for the entire process, if you see the entire process, that is 1 to A and A to 2 total path. The initial state the temperature is constant and the final state the temperature is same. So therefore the change in enthalpy is 0. Similarly, internal energy is 0. For the entire process, the amount of heat transferred, that is here the Q1 for the path 1 to A Q1, and this is for path A to 2, and this is take a Q1 Q2, so Q1 plus the Q2, that is minus 5600 joules. Similarly, the work required will be 5600 W1 plus W2, that is 5600 plus 0, so that is 5600 joules.